Okay, this video is strictly designed for two people. I'm not going to say the names because saying names without their permission of non-public figures without their permission is illegal. But it is designed for two people. There might be a third that I include in the email. We'll see how tomorrow goes. Now, in these two videos, you're going to watch the first one, then work the 4 problems on your own. Then you're going to watch the second one. I got 4 problems. This is kind of more advanced level algebra, okay? Well, in this class, in Algebra 2, these first 2, you're going to need to know how to do. But then anything after the first 2 is kind of stuff that you might encounter in Coach Larson's trig class or in your college level math class. So that's kind of what it's designed. It's to prepare you for things for the future. But this in my class, these first couple, on the standards, you are expected to do these 2 problems. Okay, so I have to solve the equation. I know there's 2 solutions because I see x squared. Now, as far as how I'm going to arrive at the 2 solutions, we know we got x second, and I don't have x that is to any other power, so it's x squared only, okay? So you just need to get the x squared by itself. So you're going to accomplish that, of course, by subtracting 3. That's 80. And then dividing by -2, which is -40. And now the inverse operation of the second power is a square root. So that cancels, gives you x. Okay, now, when you have a negative and a square root, now negatives don't have any real numbers as square roots, so we make this thing called imaginary numbers. I know that sounds ridiculous, but I'm going to kind of make it come to life over here after I'm done. So what I do is I make that positive and I extract an I outside. Okay. Now you guys might today on a piece of paper, might want to write down your perfect squares. So like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. That's probably good enough. Okay. I don't have them on the board yet because I'm not to this thing yet. Okay, so 40 is an irrational square root. It means it doesn't have an integer value, but it does divide by the perfect square of 4. So I got 4 and 40. The 4 times what's 40? It'd be 10. Okay, now the square root of 4 becomes its integer value of 2. But when I write the answer, I put an I just before the square root. Okay, so the answers are 2I square root of 10 and -2I square root of 10. Now, right here, I'm going to plug one. I'll just plug the positive one into this solution for x. Okay. So I got -2, and then when I get to the x, I put a parentheses, and I'm going to put 2I square root of 10 to the second power plus 3 equals 83. Now, what I'm about to do next is I'm going to square this 2I square root of 10. And here's how that can be. So I'm going to just square that, take it to the second power plus 3 equals 83. Now, how would you square that? Well, 2 to the second is 4. We know that. And then the I goes to the second. And then the square root of 10 to the second power means the second power and the square root of 10 cancel each other out because they are inverse operations, and I just have 10. Now, yesterday in the video, you saw I to the second is equal to -1. So that's actually 4 times -1. So what is 4 times -1 times 10? Well, that would be -40. So I have -2 times -40 plus 3 equals 83. Well, that's 80, and then plus 3 is 83. So that's the only way that equation can work in the end is if I get an I, okay? That's just for showing you. By the way, if you put a negative in front of it, it'd be the same thing because -2 to the second would still be 4. You'd still have I to the second, which is -1. 4 times -1 times 10, okay? So again, I know that was kind of weird yesterday, but I'm teaching this to a much audience functioning, much at a higher level in the last video. Not to throw shade, but yeah. Okay, now my next one says negative 4x to the second power plus 2 equals 6x to the second minus 98. By the way, when you're doing the work and the problems on your own, you don't need to do this. I'm just showing you why. Okay, so there are two solutions. Now I have x squared. I have it twice, but I don't have x to any other power, so it's x squared only. So we're going to do it like we did here, but first we have to get rid of an x squared. I'm going to get rid of the 4 by adding it, because that would be how you take that to 0, and then add it to the 6x squared, but not the 2, okay? 2 is what I do if I have to factor when I have x sets to other powers. So I have 2 equals 10x to the second power minus 98. Shoot, I didn't want that to happen. That's my bad, okay? Erase what you have. I want to change something. How about you switch the 98 to plus and then the 2 to a minus, okay? And also, yeah, that's good, okay? Yeah, that should work. Okay, so I'm going to do the same thing. I'm going to plus 4x squared and then plus it to 6x squared. The problem would have worked. I just didn't. I didn't want it to end up that way. I want this to be about i's. 10x squared plus 98. Okay, then we'll subtract 98 from both sides, and that takes that side to negative 100 equals 10x to the second power. Okay, now divide by your 10. And negative 100 divided by 10 is negative 10 equals x to the second power, okay? Now I do a square root, okay? And again, I know I have to make that an I. Now 10 is not a perfect square, but the only perfect square that 10 is going to divide by would be 1, okay? So when that happens, what I do is I just put I squared of 10 and then I squared of 10 with a negative in front of it. Okay. Okay, so when you can't divide it by any of the perfect squares other than 1, you just leave it the square root of whatever, and then the I goes right in front of it. And the reason why you don't just square root these on your calculators, because when I was having you do that before, those aren't really exact answers. They're answers that you round. Now they are exact. They make the equation work out exactly correctly. See, if I plug in a rounded decimal, I'm not going to get this side quite equal to that side. It'll be close, but it won't be dead on the money. Okay, now we're going to look at some other ones. These are... Okay, we got x to the second power minus 2x plus 2 equals 0. So I know there's two solutions to this equation. There's got to be. And I have x to the second, but I've also got x to the first. That means we have to have one side equal to 0, and then we have to do our factor charts. Okay, so you're already at 0, okay? There's 3 terms, 1, 2, 3, so it's GCFT. Okay, and again, I'll put a 1 there. So the GCF, you wouldn't do a negative, you wouldn't do x because that doesn't have x. 1, 2, and 2, the GCF's 1, so that's a waste. Okay. Now 1 times positive 2 is positive 2, so I'm looking to add to try to get to 2 in the middle, which is a negative. First, I'm going to see if I can get to 2. 2 divided by 1 is 2, but 1 plus 2 is 3. Okay, and that's really the only 2 is a prime number. That's the only factors that work, so that is a fail. Okay, the factoring part fails. So now I go to my quadratic formula. Opposite of b plus or minus d square root. B to the second, I put 2 parentheses there, minus 4ac over 2a, quadratic formula. Okay, so the opposite of b would be positive 2. b itself would be negative 2, although when you're taking it to the second power, it doesn't really matter. Okay. Then 4, a is 1, and c is positive 2. Then a is positive 1. Okay, we know 2 times 1 is 2. Now normally, what we like to do is find the square root on the calculator. It just saves me some time. So I go negative 2 to the second minus 4, 1. Or actually, I did that wrong. Second. Negative 4 to the second minus 4, 1, 2. Or sorry, dang it, I did it wrong again. Negative 2 to the second minus 4, 1, 2. Okay, I got a domain error. The reason why is because that's 4, and then 4 times 1 times 2 is 8. Well, 4 minus 8 is a negative number. Now, in college classes, when that happens, and next year in trig, okay, this is how they're going to want you to figure this out. Write your 2 answers, otherwise you'll be docked points, okay? So you have 2 plus minus, and then you know you got 2 in the denominator. Now I'm going to make a square root up here, and I'm just going to punch in the expression without the square root, okay? So negative 2 to the second minus 4. I'm guessing it's going to be negative 4, since that one's pretty easy to do mentally. Okay, negative 4. Okay, so I bring out the I, and 4 is a perfect square, because the square root of 4 is 2. So down here I put 2i. I don't put a square root, because the square root goes away, okay, completely. Okay, now, what they're going to want you to do is look at the 3 numbers, 2, 2, and 2. You can divide those all by 2. You can reduce it, so that becomes a 1, and a 1. So on top, I got 1 plus 1i, okay? And I'm not going to put a 1 on the bottom. If I have a 1 on the bottom, it's basically useless. And then 1 minus 1i. And those would be how you would write the answer in like a college course. Okay, my next problem, there are 2 solutions to this problem. Okay, you've got x to the second power, and you've also got x to the first. So again, I can't isolate x to the second because there's that x thrown in there. So I have to set the equation equal to 0 if it's not already, and then I go to my factoring. Okay, you're equal to 0, so you're set. Okay, you're set to factor. There's 3 terms. Okay. So GCF and T. GCF, you don't have a negative. X isn't on every term. 2, 4, and 7. The GCF's 1, so you get rid of that. Okay, then I multiply the A and C coefficients together. That gives me a product of positive 14. So again, I would try to be adding to try to come to 4. Now 4 is negative. Okay, so 1 and 14, nope. 2 and 7, nope. And then that's about it. Okay, so we go to our quadratic formula. Opposite of b, plus or minus the square root. So b to the second minus 4ac. Now on bottom you got 2a. Opposite of b is positive 4, and then the b is negative 4. Okay, and then 4a is 2, c is 7, and then a is 2. Okay, so you know 2 times 2 is 4. Okay, now we figure out our square root if it's possible at the present time. Negative 4 to the second, I put 2 parentheses from the get-go, minus a 4, a 2, and a 7. Yep, we got the domain here. So what I do is I make the plus minus, I put the 4 in front and the 4 underneath it, and then I make a square root up there. And then I just plug in the expression without doing the square root. So if I'm just going to do that, I just need 1 parentheses to start. 4, 2, 7. If you do 2 parentheses to start, it's going to say error because really you don't have a square root here. Okay, so it's negative 40. Now, unlike this one up here where I just got rid of the square root and put 2i down, okay, negative 40 again doesn't work out so well. okay, you make the I. It's not a perfect square, so you look through your perfect squares and see what 40 is divisible by. It's divisible by 4, okay, and 40 divided by 4 is 10, okay, so you're splitting that in. Now, we all know the square root of 4 turns into a 2 whole with an I right before the square root, so I put 2I square root of 10. Now, when I'm looking at the reducing part, I'm just looking at these numbers. I am not going to mess with the number in the square root because it's not just 10, it's the square root of 10, so we ignore that, okay? It's these three I'm looking at. 4, 2, and 4 can all be reduced by 2, so that becomes a 2. That's a 1, so that'll now be 1I squared of 10, and that's a 2. Okay, so what I do is I write 2 plus 1I squared of 10, and I need to underline it and put the 2 there. I didn't on the last one because it ended up with a 1 in the denominator. And something over 1 means you don't need the 1, but something over anything else means you need it. And then we'll just write the same thing, but we'll, instead of plus 1I squared of 10, we'll write 1 minus 1I, 2 minus 1I squared of 10 over 2. Okay. In a college course, or like Mr. Larson's trig class, that is how he's going to want you to write those answers on the quadratic formula when the I arises. Okay. Okay, work the 4 problems and let me know at the end of class if there were questions, please.